Imagine the moment when everything began, the famous Big Bang. It's a fascinating idea, suggesting that the universe arose suddenly rather than always being infinite. Until the mid-20th century, most scientists believed the universe was eternal, without a defined beginning. However, Einstein's theory of relativity revolutionized our understanding of gravity, and Edwin Hubble's observations of galaxies moving away from each other reinforced this new perspective. In 1964, almost by chance, scientists discovered the cosmic microwave background radiation, a kind of echo from the beginning of the universe. This discovery, along with other observations, solidified the Big Bang as the prevailing theory of the cosmos's origin. Since then, technological advances, such as the Hubble Space Telescope, have provided us with clear views of the Big Bang and the structure of the universe. More recent observations even suggest that the universe's expansion is accelerating. But intriguing questions remain. How exactly did the Big Bang happen? How can something arise from nothing? These are mysteries we continue to explore, with each discovery bringing us one step closer to understanding the origins of our universe. Let's dive into what we've already discovered about the universe. To start, it's important to clarify that the Big Bang wasn't an explosion in the traditional sense. Instead, it was an event in which space itself began to stretch in all directions. Imagine the universe extremely compact, starting smaller than a point and then rapidly expanding, growing to immeasurable dimensions. It didn't expand into an external space, it expanded within itself because, by definition, there's no outside of the universe. The universe is all there is. In this primordial, hot, dense soup, energy transformed into particles within fractions of a second. Gluons and pairs of quarks emerged and annihilated each other while emitting more gluons. These, in turn, interacted with other short-lived quarks, forming new pairs of quarks and gluons. In this initial state, matter and energy were so indistinguishable from each other that they could be considered the same thing due to extremely high temperatures. At some point, matter began to predominate over antimatter. In today's universe, we observe almost exclusively matter, with a noticeable scarcity of antimatter. Somehow, for every billion particles of antimatter, 1,000,001 particles of matter were formed. Instead of a single dominant force, the universe came to be governed by several fundamental forces, each obeying its own rules. Over time, the universe stretched to about 1,000,000,000 kilometers in diameter, resulting in a gradual drop in temperature. This expansion and cooling are crucial to understanding how the universe evolved into its current form. The process by which quarks emerged and transformed into energy suddenly ceased. From that point on, we worked with the elements that managed to form. Quarks began to combine to create new particles, hadrons, such as protons and neutrons. There's a variety of possible combinations of quarks that form different types of hadrons, but only a few are stable for a significant amount of time. Pause for a moment and consider that this entire process occurred in just 1 second since the beginning of the universe. At that instant, the universe had already expanded to 100 billion kilometers and was sufficiently cool for most neutrons to decay into protons, forming the first atom, hydrogen. Imagine the universe at this moment as an extremely hot soup, about 10 billion degrees Celsius, filled with particles and energy. In the following minutes, the universe cooled and stabilized rapidly. Atoms were formed from hadrons and electrons, creating a stable and electrically neutral environment. This period is sometimes referred to as the Dark Ages because there were no stars and hydrogen gas blocked the passage of visible light. But really, what's the need for visible light if there wasn't yet life to observe it? Millions of years later, hydrogen gases clumped together under the pressure of gravity, and stars and galaxies began to form. The radiation from these new stars transformed the stable hydrogen gas into plasma, which still permeates the universe today and allows the passage of visible light. Finally, light was made. But what about what happened exactly in the beginning? This is the domain of the Big Bang. We lack clarity about the events that occurred in those moments. Our tools and the natural laws we know cease to make sense, even time becomes uncertain. To fully understand those moments, we would need a theory that unites Einstein's relativity and quantum mechanics, something scientists are still developing. This leaves us with many unanswered questions. Was there another universe before ours? Is this the first and only universe? What caused the Big Bang? Was it a natural event based on laws we still don't understand? We don't know the answers, and perhaps we never will. But what we do know is that the universe we know began there, giving rise to particles, galaxies, stars, Earth, and us. Made of stellar material, we are not separate from the universe, we are part of it. One could say we are the universe's way of experiencing itself. So let's keep exploring and experiencing until there are no more questions left.